We will start from a very simple diagram, and we'll keep adding more complexity to it, understanding a build integration with MDTools software. When we need to export a diagram to MDTools, we don't need to have just that single manifold in our schematic. The schematic may be larger, and we may have several different manifolds in the same drawing. What you will see for this manifold can be then applied to more manifolds in the same drawing. We have today we look at 3 commands in HyDraw CAD, and then some other commands when we created the diagram. So the first command will be netlist, then there will be the export to MDTools, and I will also use the schematic check. When we try to export to MDTools, in the past, in previous version of HyDraw CAD, it was needed to first run the net and then run the MDTools command. In latest version, we can just directly run the MDTools export. And if we run MDTools export for this diagram, which has some mistake, as you can see, 2 ports with the same name and no connection here. If we run export to MDTools here, we have some validation error. In this case, HyDraw CAD is saying that item ID is used for multiple symbols, and this is the most relevant for the validation, and the export to MDTools stops immediately. What we can do before exporting and finding issue is using the schematic check. Schematic check in this case will check for the diagram, and we'll be able to verify for components, ports, connections, and envelopes, and we can run check. And in this case, it is saying that port T is not connected, and also that the port size is missing, and also there are 2 ports called T. When we export to MDTools, we need to have unique IDs for each item, either it is a symbol or an external port. This is because we must uniquely identify items, and that's a common rule because in case of troubleshooting, we need to be able to identify which item has a problem. So now we just change this name to T1. We specify a port size, so let me search and let me take a -8 SAE size, and the same I do here, -8 SAE size. And let me connect these 2 items. Now I could directly run the MDTools, but before doing that, let's look at the netlist. Although MDTools export would work, I always recommend to start with the netlist. Netlist run on this diagram will identify several nets. Let me bring to the primary screen here. There are, in this case, there are 4 nets, and we can click on a single net, and we can view that net in the diagram highlighted. Within this panel, we can also change the net name. So when we say this one is for instance, a T-net or tank, let me call it tank, then in MDTools, we will have directly a net called tank in the MDTools net. So it will be easier to identify. And also in our MDTools, we will be able to relate that tank to a particular color. In my MDTools setting, I have a net called T, so I leave the name T, and a net called P. And let me leave the standard name there. We can click OK. So in this case, we are validating the net in this diagram. And if we select a line, we can see on the right, let me change a bit of the color, on the right here, that line belongs to net T. So when we select a line, we can see that it is belonging to a particular net. So that means that the net command has been run in this diagram. Now we want to export to MDTools. Export to MDTools will verify something else in this diagram, which could be missing. And in this case, it is saying that component 2 has no cavity. So this is important. When we want to design a manifold, we need to make sure that all the components that we have in the diagram have a cavity. It's not important that the cavity name is correct, although it is better to have a cavity name that is correct, but it is important that we have at least a cavity name. So let's say that I name this cavity missing cavity. And in this case, the cavity is also displayed. So although my library has no cavity that is called missing, when I run the MDTools command, the MDTools command will simply work. And now, as you can see on the left, I have a panel. I normally don't care about the design units because I always work in, well, it depends on the unit you are using in the schematic. So for me, it's metric. For those using Imperial, it will be in Imperial. A material, you could select a material. It depends on the MDTools library that you have connected in HyDraw CAD. A manifold pressure if needed, but that's not so relevant. I don't give too much importance to this part, while I give a big importance to the component and external ports. When we select an item here, as you can see, we have the cavity information. Let me highlight. The cavity name is missing. And the engraving, we can change the engraving. Let's say for us, it is the check valve. So we type CV. And in MDTools, this will be the engraving for that component. We can set a preferred face. Maybe that must go on the top, right, left, and right. And we can look at the port information. And we can look at CAD files that could be linked there. We'll see in a second step to link CAD files. So we can go through each of them and see the cavity information, the port information, and CAD files. Or we can go to the nets and do again a verification on how we made the connection. This is a very simple example, but of course we can make the schematic much more complete, more complex, and still the commands will work the same way. When we are ready to design, we can export this file to our design folder, which will be my webinar. Let me go to my design folder. It's on the D drive 2020 webinar. And that's my HyDraw 2 MDTools command. And that's my exercise one. Save. Let me also close this. I don't need it anymore. Let me save my diagram. And let me jump to MDTools. So in MDTools, when we have exported, and I get back to the diagram later to do some modification. When we want to design a block from HyDraw CAD, we go to the HyDraw schematic and load the schematic file. So as you can see, we are not loading directly the DWG. We are loading an XML file generated from the HyDraw CAD diagram through the export to MDTools command. We just load it. And on the left, we will see all the commands. And now we have a warning. So when we have a cavity name that is missing, MDTools will verify if that cavity name is available. If not, it will ask us to map it. Let me take a Parker C10-2 and assign it. So now I will be able to go on and design my block in any case. So that cavity now, if I go to the component 2, we'll see that it is a C10-2. Let me create my block and do quickly my design, because then I want to do a modification to it. We can just double click on a component and touch a face and place that cavity there. A technique that I use, and you may have seen during other webinars where I started from HyDraw CAD diagram, is that a big advantage of starting from the diagram is that we have the possibility to go by net. And going by net means that we have the possibility to find by colors which item must be connected together. So we can really go and start designing by net, which is what probably most designer will go when they read the diagram on paper, and they will try just to do the connection net by net. So in this case, the approach is very similar. We can take components, double click, we can place the component on a face, and we can go on and do the just we connect colors. We don't need to worry about component selection, cavity selection, and net definition. We simply go and connect. In this case, I want to change face and position here and connect with port 1 in the center with the reference to this cavity at 0 on X. And I want to connect my cavity with port number 2. I want to align these two cavities. I want to stretch this block. And I need the cylinder port, which may be on this face, and connect it on port 2. Let me optimize the connection. Let me make a bit the block smaller. Remove 20 millimeters. And also in this face, make it 80. And that's our first design. Something very important is that although on the left, we have all the components grayed out, and when we select a component, we cannot insert again, we have one very important command that is the schematic conformance check. So it is this one, schematic check. When we run schematic check on the block, MDTools will verify if we made connection properly. And if we are missing, it will not verify if we made connection properly. It will verify if the information attached to the cavities in the block are consistent with the diagram. In this case, this port, it should be a pressure in the diagram. It is undefined in the block. So we go directly on the model, take the pip and define it as a pressure. I don't know why it came not as a pressure, but we fixed it. So this block information, the information for the cavity in this block are consistent with the diagram. What does it mean? That if I manually change, let's say that I change a net information, and let's say this net is called drain. If that net is called drain, and of course we see that the color is not correct, but we can verify with our schematic, and we can quickly have evidence of differences between the information between block that we have designed and cavities cavities in the diagram. So the cavity T should be a net T instead of a net Y. At the same time, if we replace this cavity with a different size, let me take a BSP port 1x4. If we do again the schematic check, now the differences will be more. Component T has a wrong net, and also the component T has a different cavity from the schematic. Let's go back to the diagram and do some changes to the diagram. So instead of only a cartridge valve, let me insert a surface mounted valve. And let me search D1 VW %004. And let me take this valve here. And let me do some connection. This one is going to the pressure. This one is going to tank. We put a terminator on B port, and we connect A with the cylinder. We don't make anything particular. Now let's try to export this new schematic to MDTools. So again, I want to verify if I made properly all the connections. So I run a netlist again. This warning tells me that the diagram has changed. I had already generated a netlist and now I needed to update them. So I click OK and recreate the netlist. So as you can see, the net have not changed in terms of name, but in terms of complexity, they did. We can also do another name. Let's say that this one is called cylinder, and this one we call it P internal. And click OK. Now we do again the export to MDTools. Before doing that, I also want to link some 3D model. So if the 3D model are already linked in the library, then there is nothing to do manually. You import from the library and you get the 3D model. Otherwise, you manually could link a 3D model. And in this case, that's a HyDraw WK10C valve. Okay, and we also want to link a coil that requires a coil 50 size. Okay, so we can link also two 3D model to that valve. This one also was a HyDraw RV10A. And this one we look for a D1. Sorry, in this case, I don't have many 3D model loaded in this library. So let me find for WE6, this one. Okay. Now I export again to MDTools. And again, I could go through nets again. I could go through cavities and see, define the preferred face. But now, for instance, in the components, I will see the CAD file. And this information will be useful because I will be able to make an automatic assembly of the block. So I can export my diagram to the same design folder. And let's call it exercise 2. And let's go back to my block. Let me save my block as HyDraw MDTools exercise 1. And I want also to save as exercise 2. Now on this exercise 2, I want to load the new file, new schematic. So as you can see, HyDraw CAD diagram is already in this file, but it is the old XML file. So we can load it again on top of a previously designed block. Again, that cavity was missing, so we go to the Parker. I should have fixed it in the diagram. Next time I will do it. Now what we can do is that we can compare the schematic, and normally this is what I do. When I need to change a design with a new diagram, the first thing I run is a schematic check, because I want to make sure that everything that is in my design is corresponding to my schematic. And now I want to focus on net. If you remember, I had default net names, net3, net4 in the previous design block. Now I decided to rename them. This table is giving me several important information, and I'll keep it loaded here. What I want to do is now I go to the model, nets, and I will rename my net3 into cylinder. So double click, that's my net called a cylinder, and confirm. Net4 is my net called P internal. And then also I can see that T should be a tank line. So I selected T-net. Let's compare again. Now, as you can see, those inconsistencies between net have disappeared, but I have still the cavity that is not correct. So I go back and do the replace this cavity with the SAE ports, -8. Then we go back to the schematic and we miss the component number 4. We can insert it and maybe we place on this face. Okay. If you remember, I had switched off, I had put a terminator on the schematic. So in this case, when you use a terminator, let me change color, it's red on red, blue. In this case, automatically MDTools has suppressed this cavity. And if we go to the model, port B is suppressed. Later you can decide if you want to unsuppress, delete, or hide the circle if you don't want to see the circle. But it's important that MDTools does that already switch off for you. So you just need to connect what is available. We can go on and make our design. So let me make a construction plug between this drill and the port number 1, a small expander on this face. And I don't like too much. Let me move both cavities on the. Okay, too much. Align and stretch. And then we can put a construction plug here. Okay. And we can move this cavity slightly to the right. And for the green one, we do again a construction plug. We put it here. And we do another construction plug. And we can save. Let's move this up. And our block is designed. If we do the schematic check again, this block is 100% compliant to that schematic. But this block will be 100% compliant even if I don't make all the connection. This is an important topic. Schematic check will not verify that you made a good block. Will only verify that your block, the cavity information in your block, are matching the cavity information in the HyDraw XML file. Schematic check in this case will tell me that the block is okay in terms of information in the block. But connection check will tell me that this block is not okay because T is broken. I just removed the construction plug that was needed. So don't assume that your block is safe just for the schematic check, because you may have connection issues or wall thickness issues. And so we could also do a verification for wall thickness and verify that this block is safe for 3 millimeters, maybe 4 not enough. Yes, there is a small 3.6. Let's say that we don't want to do too much modeling now. We want to make the assembly of the block. We go to make a new assembly. And since we had information from the schematic, we do the automatic assembly. Yes, we can take our exercise 2. And the exercise 2 will be automatically assembled on all the components. The NG6 valve, the cartridge with the coil, and the cavity. During last webinar, I explained how to instruct the components for the assembly. And today, during the last HyDraw webinar, I explained how to link 3D models to the component in the library. This is a demonstration of how the 3D model that we have instructed and we have linked to the components in the library, how those can be assembled automatically in the block. So there are some special cavities like orifice plugs. So let me try to find an orifice plug, a symbol for an orifice plug. Orifice plug. And I put it here. And maybe the orifice plug is connecting the P line with the tank line. Of course, we need to specify a cavity. Let's say this is an M6 by 1. And now instead of missing, I put it C10-2. So next time it is not asking me anymore. So orifice is a special situation. It will be recognized in the net list as a component. Again, net list asking to regenerate, and we recreate again. Net name stays as they are because the diagram is not different from the previous one. And we can export to MDTools the entire diagram. Export, and we go back to our design folder. Exercise 3. We go back to our block and take the exercise 2, and we save as exercise 3. And we can load again our schematic, exercise 3. There will be no differences here. There will be an orifice plug. And as you can see, the orifice plug is positioned on a particular area here. That's item 5. And if the orifice will go inside another cavity. So we can look at net information. It must be connected between tank and P internal. So we could say that we add a construction plug. Let me add from the library a G1/8 XG 1/8 cavity belonging to the tank, and we place it on top here. We stretch it, and with a double click on the cavity, on the orifice, double click, we place it here. Okay, and now the orifice is placed below the other construction plug, and now we can align these two cavities and do whatever modeling we need. The interesting part of the orifice is that it automatically changes the net information. In this case, a tank is up, and so the pressure is down. But if I delete my orifice and change the net for the plug and take it P internal, and that's a pressure net. If I take the orifice number 5, now I place on the same plug. Now it will be using the different net, because the orifice is something that bidirectional, so it will shift the net information between the one that is the source cavity of the orifice. If, on the other hand, the net of the orifice is different, let's say it's a P net, and I want to place the orifice down here, it will say that this net is not compatible with the orifice plug. So since the orifice must always go below another entity in the block, we must make sure that the net of that cavity is matching one of the two net of the orifice plug.